All right. So today we're going to talk about section 3.4. Tomorrow I'll talk more about section 3.3 and 3.4. But this is not on your quiz on Friday. Okay? Now, on the trig functions, I said it about the quotient rule. There's going to be lots of different answers. If you remember your identities, your identity note card, they have lots of identities to rewrite any solution you have involving the trig functions. So I'll spend a lot of time just answering your questions over, is this the same answer? It is if you use the right trig identity. So if you have your trig identity note card, you're going to need that for only this section, for this chapter, for the rest of the year. That card is going to be your key to answering a lot of the questions. No, you can't. Maybe on the first one you can, but that's it. So anyway, here are the big four I gave you. You already wrote these down. The limit, as theta approaches, nice to see theta again, isn't it? Limit as theta approaches 0, sine of theta equals 0. The limit as theta approaches 0. Oh, okay. Limit as theta approaches 0, cosine of theta equals 1. We had the hole in the graph for sine theta over theta. And we have the fact that 1 minus cosine theta over theta equals 0. These four are essential for doing derivatives of trig functions old school. You'll have to do a derivative of a trig function old school on your test. If you were in 7th hour, I think you did this twice.
What are we doing?
Derivatives of trig functions old school. If you were in 2nd hour, I don't even think we did it once.
You're right, we didn't.
Now, regardless of where you came from, and regardless of what you did last year, I know for a fact you wouldn't remember if I asked you to do it now. So everybody's on the same page. This is used, did you write that in your notes? These are used for the derivatives of trig functions using the limit definition. When it says limit definition, these four will come up in your work. You ready, Michelle? Excellent. Yep. Sure. It is. If you graphed out sine theta over theta and put in 0, what's the sine of 0? Sine of 0 is 0. Over 0 means there's a hole in the graph. Because the graph's getting close to 1, just like any other hole in the graph. Okay? So, we're going to do the easy one first, which leaves the more difficult ones later for the test. This is the easiest one. Find the derivative of the following function using the definition of the derivative involving a limit. That I took directly off the test, the directions. The question is y equals sine of x. You have to come up with a derivative manually without using a shortcut. What is the limit definition since you're going to do it tomorrow? Yeah? Close. I would allow that. A is usually the point that we use at the tangent line, whereas x is the variable of choice. But either way, it works. Limit as h approaches 0 of f of x plus h minus f of x all over h. Is this the limit? Alex. Is this the definition for average velocity or instantaneous velocity? It is. That's the definition also for instantaneous velocity. The average velocity doesn't have the limit in front of it. You ready? What is the function in question we're going to use? Stephanie, I think I see the problem. Exactly. What function are we working with? Sine. Good. So you have sine of x plus h minus sine of x all over h. On to Hannah. What is the sine of x plus h? Oh, she pointed quickly. Nice. What is the trigonometric sum identity for sine? Wait a minute. She's got this. Shh. You're right. Right? Very good. It is the sine of x cosine of h plus the cosine of x sine of h. You can have it written either way in the end. You don't have that, do you?
What?
This.
Oh, I got it.
Great. Because you have to have not just that identity, but any of the sum identities if you're going to go old school. There's one for sine, there's one for cosine, there's one for tangent. You can reciprocate them for secant, cosecant, and cotangent. In fact, I did that last year 7th hour because there's such a pain in the rear. We did the reciprocal ones too, just to keep them quiet. All right. So these all follow the same idea. Use the definition, pick your function, do your expansion. What was next in these problems? After you expanded, what did you do? Nope, you factored. You factored. Do you see anything that's common that you can factor in this one? Sine of x. There's a sine of x in the first and the last term, isn't there? So if you put those together, you can factor out a sine of x out of the first two, can't you? Out of the first two terms, you can factor out a sine of x. Don't misunderstand. Your variable in the limit isn't x. The variable in the limit is h. X's won't turn to 0, only h's will when you get to the end. Only h's will turn to zeros, not x's. So by factoring out this sine of x, it allows you to split this up into two fractions. Does anybody see anything similar to the big 4 that you see right now in this expression? Cosine of h minus 1 over h. Anything else? Yeah, sine of h over h. If you look at that one in two terms, remember that long division bar means you can divide each of them by h. Everybody in the room knows that sine of h over h goes where? The limit as h goes to 0. Where does it go? 1. Where does the cosine of h minus 1 over h go? I know it does. Now, this step from 2 to 3 isn't necessarily a rewrite. It's just how you think of it. This whole term right here will go to 0. This whole term right here will go to 1. You did? Yeah, same thing. I just moved it up so people could see. Oh, see, I moved it up. No! I'm trying to find an expression involving x. I'll get rid of this term. Right. But my focus isn't the denominators. My focus is the problem started in x's. It has to end in x's or something else. So you can do this for any trig function, except the reciprocals are harder. But I mean, not harder. They just take longer. So the derivative equals the sine of x times 0 plus cosine of x times 1. Remember, the 0 and the 1 came from the big 4 we just talked about. Yep. No, because you factor out a negative, and a negative times 0 is still 0. Nice. This is a template on how to do every trig function. Yep. Yep. I put in all the zeros. This term goes to 0. This term goes to 1. Remember, this equals, as Alex said, the instantaneous velocity or the derivative. So that means if you start out with the function of sine, the derivative is cosine. It is. What's the derivative of cosine, Hamer? Sine? Good guess. Well, you see this says the function is sine, the derivative is cosine. Which is kind of weird, isn't it? So what would be the derivative of cosine? Close. If you turn to page, can I change? If you turn to page 121, it's got them listed. The derivative of cosine is negative sine. Page 121, I believe. No. Some do, some don't. You need to know it. Whether you write it down or whether you just take a flash picture of it like I can. Actually, I can record video for a long period of time, but I can't take snapshots. It is. And everybody will figure out why that happens. I've tried. Believe me, I've tried. There are, how many people in this room? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and 22 people are writing things down and 2 people aren't. Interesting. I know test scores is one of those 2 people. Sine. Oh, because it reinforces what it is, and it allows to build connections in your brain. So when you see the derivative, you've already written down the connection once. The more times you write it, the closer the connections get. The closer the connections get, the faster those impulses travel, and the quicker you know the answer. Isn't that amazing how it works? It's kind of like practicing golf. You can either go out there and swing a club, or you can watch it on TV. Which would you get better at? Swinging a club. I've tried watching it on TV, and it doesn't work as well as I would hope. It's cheaper to watch on TV, but it's not as much fun. No, it's not. Very good. Write this down as a side note. This will save you probably 20 to 25 points throughout the entire year. The derivative of any cofunction is negative. The derivative of any cofunction is negative. The derivative of cosine is negative sine. The derivative of cosecant is negative cotangent cosecant. And the derivative of cotangent is negative cosecant squared. On the flip side of your identity note card,
Can you say that side note again?
yeah, the side note is the derivative of any cofunction. I don't know if this is going to work. Oh, I can do this. The derivative of any cofunction is going to be negative. Okay? You know what this does? This brings up a whole new level of problem that you can find the equation of tangent lines to. You could go back like you did a year ago and find the value for the cosecant of pi over 4, the tangent of pi over 3. You can find all those x and y values just like you did a year ago on the unit circle. Bless you. That's why you still have the unit circle along with trigonometric identities. I mean, everybody remembers what 1 plus tangent squared equals, don't they? See, there you go. It's secant squared. You're going to need those substitutions now that this has been opened up as possible questions.
How much more are we going to be adding?
If you want to know when your note card is going to be done, open up the inside front cover of your book. That's what we'll be studying this year. We're going to do the right side or left side of the column first semester, and we're going to do the right side of the column second semester. Isn't that great? Yes?
Are we going to use those board in our homework?
In your homework, yes, but not on a test. When your exam comes up, you can't have any cheat sheets. That's Parkland rule. Okay? Now, I know you're not.
We can use these shortcuts.
You can use the shortcuts on your homework. On the test, it'll ask you for the limit definition to get from one to the other one. Cosine, you can guess, probably isn't too bad. Tangent, Not bad. It's okay. Ha. Cosecant. It's got the negative and the product. That one's probably the worst. Yep. No, it's not. Okay? It only goes from 3-1 to 3-3. Okay? Exciting. I like this. This brings back all the fond memories of trig. And the unit circle. And the X's and the Y's. What did you say? Hit the button? Sure. Yeah, I thought you said hit the button. I hit the button and nothing happened. Did it go to sleep? Oh! Here we go! Well, sure it begins. No, we have the keeper of the time that's in charge. They know it's Wednesday. Nice. So what's the derivative? Woo? Birthday boy plus 1? Fantastic. It's that easy. 7 secant squared of z. It's easy now because you have the notes in front of you. In May, when you're taking the final exam, are you going to remember the derivative of tangent? It's my hope you do.
Did we take one this semester?
This semester is optional. Yeah, if you're on the borderline. Okay? If you're on the borderline between A and B and you want to take it to bump you up, you can.
But it could hurt you too, though.
No, I don't count it. If you're going to take it and you do bad, I throw it away.
Oh, okay.
Nothing? Right. Sure. Ready? Let's try another one. You want to? Quiet, please. Along with all the other rules we've been talking about in 3.3 and all the definitions we talked about in 3.2, now all the rules can be used to find the derivative of any equation. And, some people think it's simultaneous. It's not. You only do one rule at a time. You only write one thing at a time, but you can join things. For instance, if you look up here, you're going to use probably 3 rules. You're going to use the shortcut rule for for power, the w squared. You see that there are 2 w's in this expression, so that means you're going to use the product rule. Within the product rule, you're going to use the power rule and the trig rule. Sounds like a lot, goes really quick. Okay? If you ever want to make somebody feel inferior when you're working in study hall or something, say, what you're doing, or I'm taking the derivative of a function using the power rule and the power rule and the product rule along with the trig rule. They'll just look at you like, what did you just say? Oh, I said the derivative of w squared is 2w. And we all know that the power rule is the 2 drops down and you subtract 1, not difficult. Now you have to do the product rule. And somebody goes, how do you know when to do the product rule? And I always say when there's more than one variable in the expression. If there's more than one variable in the expression, you have to use the product rule. If there's only one variable in the expression, you're not going to use the product rule. I don't know how people get that mixed up, but I guess they do. Anyway, the derivative of the first times the second plus the first times the derivative of the second, which is w cosine w. I'll reiterate again. I'll do this for probably a month. There's different forms of the same answer in the back of your textbook. In fact, there's also mistakes in the back of your textbook. I find 1 or 2 new errors in the book probably a year, maybe a semester. I just found another one today. Who was that? Yeah, we found another one today. So, if you're looking in the back, you get frustrated, come and ask, and we'll try to work it out and see if it gets close, but it might be off. Yeah. Now, 1 times sine is just sine, so you're done, right? Nothing else to do? Nothing else to factor? Nice job. That was question number 6. See how difficult it is? I love this clicker. I'm going to do it again tomorrow. Saves me from writing. Oh, this one I did earlier in class today. In fact, I did it on the second homework problem. Does anybody remember what I did? I didn't separate it. No, I didn't use the reciprocal rule. I said there's always 2 choices when we come to a problem. What are they? Simplify or derivative. Quit is no option. We are Spartans. No retreat, no surrender. You were very good at this. What is 1 over cosine? Yes, you were.
Secant.
What is 1 over cotangent? Very good. I just turned a quotient rule into a product rule, which people like to do more often. They like to do product rules instead of quotient rules. And remember, you have the reciprocal identities on your note card. Okay.
Threw it away.
I don't know what it is.
What's the derivative of secant? Derivative of secant? Very good. So, I'm going to do the product rule. Derivative of secant is secant tangent. What's the derivative of... Whoa, that's not right.
You're right.
I know it. Darn it. I'll get my pants all dirty. That's okay. So K prime of X. It's a joke, whoever just said that. Secant of X, tangent of X. That's the derivative of the first times the second. Plus the first times the derivative of the second. What's the derivative of tangent? Secant squared of X times secant squared of X. Maybe just tidy things up a little bit. Oh, sure, you can factor out a secant if you want. That looks kind of cool. Secant of X. Yeah. Okay. So that'd be your final answer. I just factored the secant out. Just save space on the board, actually. And then you're left with tangent squared plus secant squared. That's close to an idea. Wait a minute. Tangent squared is equal to secant squared minus 1, so I couldn't add. It doesn't really help. Okay? I'm not solving. If I were solving, I would do something, but I'm not.
Okay.
Great!
Okay, what?
5 minutes? All right. Let me see if we got time to do one more. Technical. Oh, there we got it. Oh, no, we better not do this one. All right. So, anyway, there used to be another thing up here. Oh, I can do this. So, go through 21 odd.